Now question number 12. Number of elements in the set is P. Number of elements in the set B is Q. Then the total number of relations that can be defined from A to B is, it is 2 to the power of PQ. Every relation is a subset of A cross B. The number of elements in A cross B will be PQ. So the number of subsets will be 2 to the power of PQ. So the number of relations will be 2 to the power of PQ. Question number 13. If number of elements in A is P, number of elements in B is Q, then the number of non-null relations that can be defined from A to B is 2 to the power of PQ minus 1. Because the previous problem, 2 to the power of PQ is the total number of relations. That includes the empty set. That includes the empty relation. That has to be excluded in this problem. So it is 2 to the power of PQ minus 1. Question number 14. If there are 256 relations from the set A to the set B, where B has got 4 elements, then find the number of elements in the set A. Suppose the number of elements in A is X. That means what? 2 to the power of 4x. Why 4x? Because the number of elements in B is 4. 2 to the power of 4x is 256. This 2 to the power of 56 can be, 256 can be written as 2 to the power of 8. So 2 to the power of 4x equal to 2 to the power of 8. Bases are equal, so the powers must be equal. 4x equal to 8, that gives you x equal to 2. So number of elements in A is 2. Question number 15. If there are 123 non-null relations from A, 1, 2, 3, 4, 5 to the set B, then find the number of elements in B. Let the number of elements in B be x. Then 2 to the power of 5x minus 1, because in this problem non-null relations. So 2 to the power of 5x. Why 5x? Because the number of elements in A is 5. Number of elements in B is assumed to be x. So 2 to the power of 5x minus 1 equal to 1023. This 1023 can be written as this 1023, this minus 1 will come here and become 1024. 2 to the power of 5x equal to 1024. 1024 can be written as 2 to the power of 10. So the bases are equal, so the powers must be equal. 5x equal to 10, that is x equal to 2. In other words, number of elements in B is 2. Question number 16. Relations are subsets of Cartesian products and functions are subsets of relations. True or false? Question number 17. First subdivision. All the elements of a relation should have images. False. It is not necessary that all elements of a relation have images. Subdivision 2. All the elements of a function should have images. That is true. All the elements of a function should have images. Then question number 18. Which of the following is true? Subdivision 1. Every relation is a function. That is false. Not every relation is a function. Every function is a relation. That is true. Every relation is a function is false. But every function is a relation. That is true. Then question number 19. Let A and B be two non-empty sets. Then which among the following two collections is larger? The number of relations between A and B, the number of functions between A and B. The number of relations between A and B will be larger. The number of functions between A and B will be smaller. Now question number 20. True or false? If R is a relation from A to B, then the domain of R is A. False. The domain of the relation need not be A. It can be a subset of A. If A and B are finite sets such that number of elements in A is P, number of elements in B is Q, then the total number of functions that exist from A to B is Q to the power of P. Now we are considering functions from A to B. So the total number of functions that can be defined is Q to the power of P. Question number 22. If the number of functions that exist from the set A, which contains the elements P, Q, R, S, to the set B is 1296, find number of elements in P. Let the number of elements in B be assumed as x. That means what? X to the power of 4 equal to 1296. That is x to the power of 4 equal to 2 to the power of 4 into 3 to the power of 4. This 1296 is factorized like this. Now this is 2 to the power of 4 into 3 to the power of 4. That can be written as 2 into 3 whole to the power of 4. That is x to the power of 4 equal to 6 to the power of 4. Powers are equal, so bases must be equal, x equal to 6. In other words, number of elements in B is 6. Question number 23. If f of x is x squared plus 1 by x squared, show that f of a equal to f of 1 by a. Let us find f of a. What is f of a? Instead of x, we have to put a. So a squared plus 1 by a squared. What is f of 1 by a? Instead of a, we have to put 1 by a. So 1 by a whole squared plus 1 by a whole squared. That is 1 by a squared plus 1 by a squared. 1 squared is 1, a squared. Now this 1 by a squared is nothing but a squared. So 1 by a squared plus a squared. From 1 and 2, f of a is the same as f of 1 by a.